What are the major advantages with respect to competitor sensors?
So generally, the SGP40 offers a much lower power consumption and thus also lower self-heating. You benefit from the strong Sensirion support and also from the stable hardware over lifetime. With respect to the analog sensors, big advantages are that we offer our VOC algorithm, which will do the entire signal processing, and also the humidity compensation is included, which is executed on chip. And overall, it's also an advantage that you have a digital interface. And with respect to the digital sensors, our VOC algorithm offers the possibility to visualize also linear events. And on top of that, the D2D, so the device-to-device variation in the field is very excellent.
What is the VOC index in ppm value? For example, what will be the equivalent in ppm to 100? And how is this related to air quality standards?
So our VOC algorithm is constantly adapting its calibration parameters to the situation the sensor is exposed to, which means that under field conditions there is no such relation between the ppm value and the VOC index. But under controlled lab conditions, if you let the algorithm train on a specific VOC event that you can control, then you have sort of a correlation between the ppm values of this particular gas and the VOC index. Our testing guide, which you can find on our homepage, is also describing this procedure, how you can do this. But again, this is not a relation that is valid under field conditions. So if you want to map a VOC value to a standard, you would actually need to measure all the individual gases of VOCs that are present in an indoor environment. And single signal MOX signal cannot offer this option.
SGP30 sometimes sets the baseline on completely different conditions. Has this been improved with SGP40? And how does the sensor respond to the situation when it is brought into an environment that already has elevated VOC levels?
Yes, there has been an improvement with the SGP40. So the VOC algorithm automatically adapts to any indoor environment, and so it becomes very independent on the baseline conditions. But it is also true that if you start up the sensor in an environment that has already elevated VOC levels, the VOC algorithm will interpret this as average conditions. However, if you again improve the air quality, for instance, you open the window, or your ventilation is going to exchange the air, or the air purifier is going to remove some of the VOCs, the VOC algorithm will also show this improvement still of the air quality.
Are there drivers available for the SVM40 evaluation board, for example for Arduino?
Yes, there are already drivers for embedded platforms available as open source code on GitHub. And there will be also in the future example implementations for embedded platforms like Arduino and so on. And we also regularly update our documentation of the SVM40. So for that, just visit our landing page of the evaluation kit, where you will find all the information.